formal charge is just a way to assign charges to kind of show where the electrons tend to be. It's a tool that you'll use as you go on in chemistry, and so we're just going to introduce you to the idea here. So it's hypothetical, it's not like a real charge. It just kind of gives you an idea of where it tends to be. And to get it, you take the number of valence electrons that the atom normally has, and you subtract the bonds, and then you subtract the lone pair electrons. And an easy way to say this, and this is how I usually think of it, is that the formal charge is equal to the number of valence electrons it normally has minus dashes minus dots. This works as long as you make your bonds as dashes. If all of your bonds are written as dashes and all of your lone pair electrons are written as dots, then this easy way works. Okay, and then the point of this is that as you go on in organic chemistry, you can try different structures and you can figure out which one is better, because the one that is better has the lowest formal charges. And if the number of formal charges on the two molecules are the same, then the best one will have a negative charge on the more electronegative element. Electronegative element, which makes sense. Let's just work a few examples. Okay, on this one, let's look at the formal charge on the hydrogen. The formal charge on the hydrogen is the number of, remember it's formal charge equals valence electrons minus dashes minus dots. So for the hydrogen, the formal charge is 1, the number of valence electrons hydrogen normally has, minus the dashes, and then it has no dots. So the formal charge on that hydrogen is 0. It's neutral. Let's try the nitrogen. The formal charge on the nitrogen is equal to the number of valence electrons that nitrogen normally has, which is 5. Then minus dashes, minus 4 dashes, minus dots, there are no dots. So the formal charge on that nitrogen ends up being a positive 1. And we would normally put that on the structure as a charge with a circle around it like this. If you think about it, all of these hydrogens are going to have formal charges of 0, because all of these hydrogens have the same number of valence electrons, the same number of dashes, and the same number of dots. So the only atom that has a formal charge is nitrogen, and it's positive 1. This polyatomic ion overall has a positive 1 charge, and that's not a coincidence that it works out that way. Let's try another one. Let's do the formal charge on this oxygen. So the formal charge is equal to the number of valence electrons that oxygen normally has, which is 6, minus dashes, there are 2, minus dots, there are 4. So the formal charge on that oxygen is 0. And let's try this carbon. Formal charge is number of valence electrons it normally has, which if we look on the periodic table, that's 4, minus dashes, minus dots. It has a formal charge of 0. Okay, let's do some formal charges on this molecule. For this oxygen, I start with 6 valence electrons, minus 2 dashes, minus 4 dots. It has a formal charge of 0. On this oxygen, I start with 6 valence electrons, minus 1 dash, minus 6 dots, it has a formal charge of -1. So I'm going to put it right there. Let's go ahead and do the carbon. Carbon has 4 valence electrons, -4 dashes, -0 dots. It does not have a formal charge either.